Hello everyone. Okay, so in this video, we are looking at complex numbers again, but more specifically, we are looking at polar form. So what is polar form? So we have been writing complex numbers in the form a plus bi. This form is called Cartesian form or rectangular form. So for example, 3 plus 2i is an example of a complex number in rectangular or Cartesian form. So, where A and B represent the position on the complex plane. But we can also represent a complex number in polar form. So, the definition of polar form is this. We can rewrite it as or times cosine theta plus I sine theta, where or represents the modulus of my complex number, and theta is the argument of the complex number. And theta is usually equal to tan inverse the positive sense of b over a, so the imaginary part divided by the real part. So theta represents the angle that the complex number makes with the positive real axes. We will also consider 0 to 360 or 0 to 2 pi. So for the purpose of this video, we're going to make our arguments going between 0 and 2 pi or 0 and 360. General convention is you go from minus pi to pi, but in these series of videos, we're going to be throwing convention out the window and we're just going to be doing from 0 to 2 pi. So when we're writing complex numbers in polar form, we must pay attention to the position of the complex number in the complex plane, as this will affect our argument. So a or g bracket z, that's how we say the argument of my complex number. We can calculate the value similarly to calculating the angles in trigonometric equations using alpha as a reference angle. So here's an example here. A complex number is in the first quadrant here. This is my reference angle, but this is also my argument because this is the angle it makes with the real axes. If my complex number was in the second quadrant, it'd be pi minus my reference angle. Third quadrant, pi plus my reference angle. And if it was in my fourth quadrant, it's 2 pi minus my reference angle. So all you need to remember, polar form, do you get it because it's Amy Polar? But right. All you need to remember, polar form is or times cosine theta plus I sine theta. Or is the modulus, and theta is the argument. Right? There, look at her. She's happy. She loves polar form. She did not invent polar form, by the way. I was trying to think, that'd be funny. And in hindsight, it actually was not funny. Right. So, how to convert to polar form? So, we sketch the position of the complex number. We find the modulus or. We find the reference angle alpha, taking tan alpha equals b over a as the positive. And then we find theta, or the reference the argument, by using the appropriate sign for our answer. So like whatever quadrant is in, and are we adding or minusing? So let's have a look at this one here. 3 plus root 3i. So first step, let's calculate my modulus. That is going to be 3 squared plus root 3 squared. That is going to be equal to root 12. Next step, let's get my argument. So we plot this out here. Boom, boom. Just doing a rough little sketch. So it's positive 3, so it's on the positive x-axis, and it's root 3. So I'm going to say it's here, right? Doesn't necessarily mean it actually is here, but I'm just sketching it out. So this is my reference angle. What I do know is, if I bring a line down here, I made a right angle triangle. So my coordinate is 3 plus root 3i. Therefore, my height is root 3 and my base is 3. Because the base will be my x coordinate, the height will be my y coordinate. So tan theta is going to be equal to root 3 over 3. Theta is going to be equal to, take out your calculator. Now, I usually work in radians for this. I usually tend to work in radians. If you can work in degrees as well, but I tend to work in radians. So tan inverse root 3 over 3 gives me 1 over 6 pi, or we can write that as pi over 6 radians. So There's my reference angle. Need to find my arguments now. So remember, we go back up to that little graph here. If it's in the first quadrant, it's just my reference angle. If it's in the second quadrant, it's pi minus my reference angle. Third quadrant, pi plus my reference angle. 2 pi minus my reference angle if it's in the fourth quadrant. So if you can see here, my complex number is in the first quadrant. So therefore, my argument is just going to be equal to my reference angle, which is pi over 6 radians. So let's put that in. So z is equal to root 12 times cosine pi over 6 plus I sine pi over 6. And that is my answer in polar form. So let's just have a look on GeoGebra and see how this looks. So we're on the GeoGebras. So I need to go from, so it's 3 on the A, and then it's square root of 3. How does one do square root of 3? Boom, boom, boom. There we are. So this is just in degrees, but I have 2 root 3, so I can actually rewrite root 12 as 2 root 3. Didn't think of doing that. 2 root 3 times cosine 30 plus I sine 30, and 30 is equal to 1/6 pi. So I am correct there. So what is the point of polar form, you are asking me? So the point of polar form is we can perform more operations on it, like adding, subtracting, multiplying complex numbers, a lot easier with polar form, which will be covered in the next video. But let's just look at this here. So I have 2 root 3 cosine pi over 6 equals I sine pi over 6. So you're telling me this is equal to root 3 plus root 3i. So let's test it out, right? Meatballs, burgers, same thing, different shape. Let's put cosine pi over 6 in the calculator. So this is my final answer, by the way. This is my final answer, but I want to show you that the left-hand side is equal to the right-hand side, and this is how you check your answer. So 2 root 3 times cosine pi over 6. Put that in your calculator. Make sure your calculator is in radians. Cosine pi over 6, which is equal to root 3 over 2 plus I sine pi over 6 is equal to a half I multiplied in, I get here 2 root 3 times root 3 over 2. That will just be equal to root 3 times root 3, which is going to be equal to 3. 2 root 3 times a half is just going to be root 3i. So there you go. I have proven the left hand side is equal to the right hand side. So my final answer is this here. This is polar form. Right. Let's just look at another example here. So we have this example here. What about minus root 3 plus I? Let's test this one out. So first step, get my reference number reference angle, get my modulus. That is going to be equal to minus root 3 squared plus 1 squared, which is equal to root 10. Then let's calculate my reference angle. So do a rough sketch. I cannot draw a straight line. Ding, ding. Straight line minus root 3 on the x-axis. I'm kind of going over to the left. Plus I, and I'm going up here. So this is 1. This is root 3. So, reason why I said root 3 and not minus root 3 is because we can't have negative lengths on triangles. So, let's do this now. So, it's going to be tan theta is equal to 1 over root 3. Theta is equal to 1 over tan inverse 1 over root 3 Boom. That is going to be equal to 1/6 pi. But now let's calculate my reference angle. Not my reference angle, sorry, my argument. So first quadrant is just my reference angle. Pi minus my reference angle, pi plus my reference angle, 2 pi minus my reference angle. I'm in quadrant 2. So theta, or my argument, is equal to pi minus 1/6 pi, which is 5 pi over 6. That's my argument. Then in polar form, this is equal to root 10 times cosine 5 pi over 6 plus I sine 5 pi over 6. And that is how we do polar form. So, something you just have to be careful of here as well. What if one of my points is on an axis? Right? What if one of my points is on an axis? So let's take this for example. Say I have the complex number 0 plus 8i. Right? So, actually, let's say 0 minus 8i. Let's make it crazy. Let's convert this to polar form. So, I have 0, the square root of 0 squared plus minus 8 squared, which is going to be equal to root 64, which is equal to 8. So, my modulus is equal to 8. Let's plot this out. Bing, bing. So, I'm 0 on the x-axis, but minus 8 on the y, so I'm down here. Now, we can't use my general rule of tan inverse positive of b over a, because I'm just left here with tan inverse 8 over 0. And I can't have 8 over 0. I can't have anything divided by 0. So how do we know what my reference angle is? So if we look here, I have the x-axis here. I'm looking for this angle. This is my reference angle. Right? This is my reference angle. This is what I'm looking for. And all I know is I can go up in 90s. This first quadrant is going to be 90 degrees. Next one's going to be 90. Then the third quadrant, it moves another 90. So that is going to be pi over 2, pi over 2, pi over 2, which is my argument then. It's going to be equal to 3 pi over 2. That is my argument. And to convert this to polar form, it would be 8 times cosine 3 pi over 2 plus I sine 3 pi over 2. Right, and that is converting to polar form. I hope you enjoyed this video, and I'll catch you guys later. Bye.